want to talk about Chapter 4, Number 7 in OpenStax. The question reads, colorful fireworks often involve the decomposition of barium nitrate and potassium chlorate, and the reaction of the metals magnesium, aluminum, and iron with oxygen. A, write the formulas of barium nitrate and potassium chlorate. So for this activity, pull out your periodic table. We'll need to look at the group numbers of the different elements and also pull out a table of the polyatomic ions. Okay, the polyatomic ions very commonly are nitrate, sulfate, chlorate, and they're composed of more than one atom. Now in part A, we're asked to write the formula for barium nitrate. Barium is a group 2 element. If you find this, it's in group 2 of the periodic table, so its charge is +2. Nitrate is not just nitrogen, it's NO3. It's nitrogen with 3 oxygens. And it has a charge of -1. So you need to memorize that polyatomic ion nitrate, okay? The way we arrive at the chemical formula for this, one of the easy ways is to do a crisscrossing of the charges, okay? So I'm gonna write the 1 there just so we can see that. And we're going to place parentheses around this polyatomic ion. We're going to take the 2 from the charge of barium and create a subscript here. And we're going to take the 1 and bring it down. And the subscript of 1 we won't show, but that applies for the barium. Okay? So what we get for this is barium, just one of those, we don't show that. And then we have nitrate. And we have 2 of those because we pulled the 2 down, okay? So that's the formula for barium nitrate. The hard parts are getting the charges. Group 2 is barium, that's rather easy, but nitrate, you're just gonna need to memorize that. The next one is potassium chlorate. Potassium, if you look in your periodic table, is a group 1 element. Okay. I'll write the 1 here, we might need to crisscross, who knows? So potassium is a group 1 element, its charge is +1, and chlorate is a polyatomic ion that you're just going to need to memorize. Chlorate is ClO3-. And I'll put the charge here. Now in this case, since we have a +1 and a -1, those 2 ions can just come together and create a neutral formula of potassium chlorate. Okay, so the formulas for barium nitrate and potassium chlorate are here. That's for part A. Okay. In part B, we want to write what happens when the decomposition of solid potassium chlorate leads to the formation of solid potassium chloride and dioxygen gas. Write an equation for the reaction. Okay. So we had discussed previously what potassium chlorate is. It's this guy here, and they're telling us it's solid. So we do indeed want to write the states for this chemical reaction. Remember, S stands for solid, L stands for liquid, G stands for gas, and AQ stands for aqueous, which means it's dissolved in a water solution. Okay? So the decomposition of solid potassium chlorate leads to the formation of solid potassium chloride. So what is potassium chloride? Potassium, remember again, is a group 1 element, so its charge is +1. Chloride, it comes from the word chlorine, and chlorine is a group 7 element, and all the group 7, or the halogens, are all -1 when they are present in ionic compounds. So this ionic compound can just be put together by bringing each one of these together, giving you a formula of KCl. Okay? I'll move my arrow over. We'll see how we'll have to balance this in a second. So it says solid potassium chloride, so be sure to write your state in there. And diatomic oxygen gas is formed. Most professors won't say dioxygen, they'll just say oxygen gas, and you need to memorize which elements are diatomic. And for that, we use Brinkelhoff. Brinkelhoff sounds like a name, and the letters here kind of spell out the element symbols. So bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine are all your diatomic elements. So what that means is that O2 is the formula for oxygen. That's the element, okay? So up here we want to write O2, and it's a gas, as we know. All right, and so we need to balance this chemical equation. It says write an equation for the reaction. It doesn't say if it's balanced. You probably want to balance this, okay? What you'll notice is that oxygen comes in groups of 3 here, and oxygen comes in groups of 2 there. So how do we get 3 and 2 to ever match? The way to do that is to look for the common multiple. We use that trick all the time in chemistry. That is to say 3 times 2 is equal to 2 times 3. So if we put a 3 in front of this, there are now 6 oxygens. If we put a 2 in front of this, we multiply the coefficient 2 by the subscript 3 to get the total number of oxygens. So we have 6 and 6. So the oxygen is now balanced. Now we need to balance the other elements in this chemical equation. There's 2 potassiums, so we need to increase the amount of this, so there will also be 2 potassiums. Now we check chlorine. There's 2 chlorines and there's 2 chlorines, okay? So this is how you figure out and you get the answer for B, okay? In part C, they tell us to describe the decomposition of solid barium nitrate, which leads to the formation of solid barium oxide, diatomic nitrogen gas, and diatomic oxygen gas. Write an equation for the reaction. So remember again that barium nitrate had this formula. In this word problem, they're telling us it's a solid, so we need to write S next to that chemical. And then this is going to lead to, right? So that means reaction arrow. And that's going to form solid barium oxide. So what is barium oxide? Let's think about that. Barium, remember, is a group 2 element, so its charge is +2 or 2+. And oxygen is in group 6 of the periodic table, and oxygen is going to have a charge of -2. Oxygen has a charge of -2 when it is present in ionic compounds. To get a neutral formula for this compound, we just stick one of these together with one of those, and so we get BaO. All right. The word problem says that this substance is a solid, okay? And it forms diatomic nitrogen gas and diatomic oxygen gas. Now remember again, if the word problem left off diatomic and diatomic, we would know from Brinkelhoff that both nitrogen and oxygen are diatomic. I'm kind of running out of space here, so I'll continue the equation down below. Be sure to write your states for these chemical reactions, okay? Nitrogen is a gas. Oxygen is a gas. Okay? So having the correct formulas is one part of this problem. Having the correct states is another part. And then having the correct coefficients is the last part, okay? So how do we balance this, all right? It's pretty crazy looking, okay? We've got oxygen in 3 different formulas. We have nitrogen in 2 formulas. And we have barium in 2 formulas, okay? First, let's just check to see if it's balanced. So we have 1 barium, okay? We have 2 nitrogens right here, okay? Because there's 2 nitrates. So 2 nitrates is 2 nitrogens, and there's 2 nitrogens. And for oxygen, it might appear at first glance that we have balanced oxygen, But look, there's actually 6 oxygens in this term because we have 2 nitrates. Each nitrate has 3 oxygens, so 2 times 3 is 6. So there's 6 oxygens in this term, barium nitrate, but there's 1, 2, 3 oxygens over there, okay? So again, balancing chemical equations is kind of trial and error, all right? So you could pick one of the elements and try to work on it. We said oxygen was not balanced, so maybe we could try to balance the oxygens, okay? Or we could try to balance the nitrogens, okay? The nitrogen's already balanced. So this is a pretty challenging problem to balance, okay? You could just try fiddling with things and see how it works out, okay? So let's try to double the amounts of that and see what happens, okay? So I'm sticking a 2 there. Let's see what happens. So we need to balance, let's now try to balance barium. So there's a 2 in front of that, so I need a 2 here. Okay, so I have 2 bariums, 2 bariums. So barium is balanced, okay? Let's look at the total number of nitrogens. There's a coefficient of 2. There's a subscript of 2 for the nitrate, right? There's a 1 there as well. So 2 times 2 is 4, so there's 4 nitrogens. There's 2 nitrogens here. So I'm going to double that now to make there be 4 nitrogens. Okay, so nitrogen's balanced. Now let me try to do oxygen and see if it works out. So I have a total of 6 oxygens in the formula, right? There's a 3 here and a 2 here, so there's 6 oxygens. But there's a 2 in front of that, so there's a total of 12 oxygens. Okay, 12 oxygens. And over here, I have 2 in front of that, and then I have just O2. So I need 12. So these come in groups of 2, so I need to put a 5 in front of this. Because 5 times 2 is 10. Okay? And so I have 12 oxygens and 12 oxygens. I think I may have just randomly figured this out. Okay, so let's double check. We got 2 bariums, 2 bariums. For nitrogen, I have 2 nitrogens. Times 2 is 4. Okay, so 4 nitrogens. Over here, I have 2 times 2 is 4. Okay, so nitrogen, double checking everything. And oxygen, I have 6 oxygens in this term. Times 2 is 12. Okay, and I have 2, there's just a subscript of 1 not shown there, so 2 there, all right, and then 5 times 2 is 10, so that comes out to 12, 12 and 12 are the same. So yeah, this is a balanced chemical equation now. So looking back on the strategy, I just stuck a 2 somewhere and then tried to balance it. If that didn't work, I try to put a 2 somewhere else, or maybe a 3 somewhere, and just work off of that, okay? It's a bit of trial and error. There's no correct way to get the final answer, okay? Now let's do part D here. Part D says write separate equations for the reactions of solid metal, magnesium, aluminum, and iron with diatomic oxygen gas to yield the corresponding metal oxides. Assume the iron oxide contains iron 3 plus ions. Okay, so we're going to write separate equations. So we got magnesium, all right, which is a solid metal, they say, so make sure you write solid. And we want to write this reaction with diatomic oxygen gas. Remember, oxygen is diatomic. It's a gas. And it's going to form a metal oxide. So let's think about what the formula of magnesium oxide is. Magnesium is +2 when it's an ionic compound present, right? When it's an ion present in ionic compounds, because it's a group 2 element. Oxygen is a group 6 element, so it's -2. To get the formula for magnesium oxide, you can just stick these 2 together because the charges match. This substance is a solid, They don't say if the corresponding metal oxides are a solid or a liquid or a gas, but I can assure you that all the metal oxides are solid. We're familiar with rust. We'll do that in a bit. This is a solid as well. Now we need to balance this, okay? Oxygen is not balanced. There's 2 here, and there's 1 there. So we're gonna put a coefficient of 2 in front of here, and now the oxygen is balanced. Don't call it quits there. Double check everything, okay? You'll now see that there's a 2 in front of this, so there's 2 magnesiums here. So to fix that, we have to put a 2 in front of that, okay? If you're just starting out and kind of shaky, double check every element at the end to verify that you are correct. 2 magnesium, 2 magnesium, 2 oxygen, 2 oxygen. So that's it for this problem, okay? The next element is aluminum, okay? Aluminum, as we know, is a solid. All right? It reacts once again with diatomic oxygen gas to produce the corresponding oxide, which we call aluminum oxide. So what is the formula of aluminum oxide? If you look at the position of aluminum in your periodic table, it's in group 3, okay? If you number your groups in the recommended way, group 3 skips over all the transition metals, and you've got boron, okay, and then aluminium or aluminum, as this word problem says, okay? So group 3 is aluminum, so we know that aluminum should be +3, okay? Next, what we do is we write down the formula for oxide. Oxide, when it's ionic, is going to be -2, all right? And what we want to do is use these charges in a crisscrossing fashion to figure out what the formula for aluminum oxide is. Okay, the 2 is going to come down here, all right? And the 3 is going to come down and create a subscript for the oxygen. So it's Al2O3. All right, let's write that over here. So that's aluminum oxide, okay? There's a 2 for the aluminum and a 3 for the oxygen, and it comes from the charges, okay? The 3 for the aluminum swings down to be a subscript for the oxygen. The 2 for the charge of oxygen swings down to become a subscript for aluminum. The crisscrossing procedure is very useful, okay? Next, what we need to do is balance this chemical equation, and the trick we want to use here is to recognize that oxygen comes in units of 2, oxygen comes in units of 3 over here, so we want to use the common multiple trick. We want to put a 2 in front of this and a 3 in front of this. That way, 3 times 2 and 2 times 3 gives us 6 oxygens on both sides of this chemical equation. Now, if we look at aluminum, we can see there's 4 here, so we're going to need to put a 4 in front of this aluminum here. Now, this is a balanced chemical equation. Okay? Next up, we have iron. It says assume iron is +3 ion. So we write iron, okay? It's a solid. Oxygen, which is a gas. And then we need to figure out the formula before we balance this chemical equation. They're saying assume iron is +3. So when we combine that with oxide, we once again use the crisscrossing procedure. And that gives us Fe2O3. So again, the charge of +3, the 3 part of the iron, is going to come down and be the subscript for oxygen. Okay, so make sure you just don't bring it down, but you crisscross it over. The 2 for the charge of oxygen comes down to be the subscript for iron. To balance this, it's going to be exactly the same as the aluminum. All right, you're going to have a 2 in front of the iron, okay, and a 3 in front of the oxygen. That gives you 6 oxygens on either side. And to fix the iron, we need to recognize there's 4 irons over here, so there's 4 irons here. Okay? I forgot to put states on these. Let's go back and fix that. The state here would be expected to be solid. Okay, and the state for rust, you think about a rusty shovel, the rust is a solid material, okay? All right, so everything has the correct formula, everything has a state, and then we have correct coefficients for everything. Notice how in this top equation, we don't write coefficients of 1 in a balanced chemical equation, we just leave it off, okay? And that concludes question 7. I hope this reviews a bit about ionic compounds, nomenclature, and balancing chemical equations. Thanks for watching, and please subscribe as it's completely free and you can always change your mind later. Take it easy.